Hello guys, in this video let us see how to achieve the required current rating to charge the battery so that we could able to feed the loads in the AC side using available solar panels. So the battery charging time depends upon two factors. One is the ampere hour rating of a battery and the second one is the charging current which is coming from the solar panels. So the ampere hour rating is going to be fixed one once you decide the battery size and the battery bank size. It is going to be a constant value, and depending upon the light availability, the solar cells is going to give the different current at different time period of the day, from morning to evening. And this current is going to charge the battery. And of course, when you are connecting the load, it is going to be discharged. The discharging of the battery is mainly depends upon the connected loads. So based upon the number of loads or the power taken from that particular load, the battery discharges. And this means the the more you have the current at the input side to the battery, the less the time it takes to charge. Say, for example, you have 100 ampere hour battery bank and you have a panels which can produce 5 amperes at a time at a given time. So this means it would take 20 hours to charge the battery fully. In case if you have two panels of the same kind, which means that current can be summed up by connecting it in the parallel. So this means it would take only 10 hours. So if you have four panels of the same kind, that means you will be able to achieve 20 amperes of charging current. This means it would take only 5 hours to charge this battery fully. So this means based upon the size of the battery and based upon the load consumption, how much percentage of the battery is discharged. So we need to have the number of panels to be connected in parallel connection so that you will get a more charging current so that it would take a lesser charging time, because the effective time for charging using solar panel would be 4 to 5 hours per day. So after that, you will not be able to get that much high charging current from the solar panels. So this means within this 4 or 5 hours, you should be able to charge your battery fully. So let us see how it is achieved in this parallel connection. So you can see a simple graphical representation here. You can see I have three solar panels, and this the solar panel positive terminals are connected together and the negative terminals are connected together, and these positive and negative common terminals will be connected to the charge controller. From the charge controller it will be connected to the battery system, so that the current of these three panels will be added up. So say for example, each panel would able to give 5 amperes. This means the total current which you can draw from this panel at the optimal condition will be 15 amperes, and the voltage of these three panels will be remain same. Say for example, you have a 20 volt VOC for these three. In VOC condition, the parallel connection, the voltage remains same, and the 20 volt will be available across these two terminals, but the current is getting added up. So it is also a KCL and KVL law applies here. You can see here the same thing is given, but with a graphical representation. Again, you have a 6 volt panel, and the current rating is 3 amperes, which is connected in parallel. So this means the voltage is going to be 6 volt and the current is getting added up. So you get 9 amperes as a output current rating. So compared to single panel connected to the battery, now you will require only one third of the time for charging the battery. So to measure the VOC in a parallel connection, we will have the panels to be connected like this in parallel connection. So you will short both positive terminals and both negative terminals in the other side. The positive terminal connection point will be connected to the isolator one terminal. The other terminal will be connected to the voltmeter. In the same way, the negative terminals will be connected to the isolator. The another terminal, the output terminal, will be connected to voltmeter common. So now when we are closing the isolator switch, that means the voltmeter can read the voltage. So you okay in this slide you can see that the panels are connected in parallel, and the positive terminal of both panels are connected together, and the negative terminals of both panels are connected together, and these two terminals are connected to the isolator. From the isolator, it is connected to the multimeter in voltage DC mode, and the DC reading 19.2 volt is coming over here. Since the panels are connected in parallel, you get 19.2 as a voltage. And about the short circuit test, in the same way we connect the panel and then the isolator, and but now we have the meter selected in a ammeter range or ammeter mode. So now the ammeter reads the current, short circuit current, when we close the isolator. So this would be the current coming from the panel 1 and panel 2 added up, and this will be shown in this ammeter. So this would be something like this. You get 8.98 here approximately. So this means the current ISC short circuit current of both panels are getting added up, and it is coming almost 8.98 for the given lighting condition. Okay, so in the panel specification, it would be in the ideal situation how much it would give, that rating will be given. It will be for this panel, it is almost like a 5.5 amperes. But for the specific lighting situation, what we measure, we get this 8.98. So this is how we can able to measure the short circuit current and open circuit voltage for the parallelly connected load as panel. And we let us see one small video for. So we can see the panels are connected here. So these are the two panels which I am using for measuring the ISC and VOC. So both panels are connected in parallel connection. So you can see both the positive terminals are connected together and both negative terminals are connected together, and the multimeter is kept in ampere mode, and you can see the reading, it's almost 9.73 amperes. Now you can see the reading. So this is the reading for the given lighting condition. So for measuring the open circuit voltage, so I shall keep the meter in voltage mode and keep the probe in voltage connection point. So you can see the voltage is 18.98, so which is the same value for both panels. So you will get a common voltage, but the current is getting added up. Hope it is clear. Let us see in the next video how to charge the battery using charge controllers. Thank you.